All right. Thank you all for joining us today. This is the second virtual field tour for the dry farming project this year. And we're going to be featuring soil management. And you can see our full schedule there in front of you, as well as at the bottom of that page, there's a link. And that link we'll share at the end as well and in the chat box, but that's going to be where this presentation and all these presentations will be recorded and archived for those who were not able to join us today. Next slide. So there's a lot of different approaches to soil management and dry farm systems. I have had the opportunity to visit with a lot of farmers locally here in Oregon, as well as down in California, who have different approaches. So to conserving soil moisture, managing their soil in a dry farm system. So one of our objectives throughout this project is just to gain a better understanding of best management practices for dry farming in our region, the Maritime Pacific Northwest. I know that there's folks on this call or on this meeting today that are from other areas. So we have a Mediterranean-like climate with a very dry summer. So we are doing a variety of things to conserve moisture from our winter rain for summer crop growth. So the study that Matt's going to be highlighting is one that we've designed to kind of explore some of these different mulching and fertility treatments and their effects. And then at the end of this presentation today, I'm going to just talk about some kind of more informal exploratory projects we're conducting with the Dry Farming Collaborative to learn more about low and no-till approaches. On the next slide. So when we talk about, there's kind of a typical approach that, you know, with all the folks I visited with, there are kind of some standard practices that we are doing to conserve soil moisture and build soil health. And cover cropping is one of those. So cover cropping is one of those. Fall planted cover crop, typically a legume cereal mix. That in the springtime, as early as possible, we will then mow and incorporate that as soon as site conditions allow. And that's just so we can get started planting early as well, and have our young plants be able to take advantage of spring moisture at the surface, because the soil will dry down in our dry summers. Surface protection is another key practice, and that looks at different ways on different farms. But on the right, you can see a picture there on your screen of me kind of pointing to this cracking soil. We have a lot of soils with clay content in the Willamette Valley. And in the spring, when the soils start to dry down, you'll see this cracking. Or after you've tilled a soil or prepped a seed bed and you get a rain event in the spring, you kind of get this crusting and cracking. So a lot of the practices that are just simply to prevent this crusting and cracking, which causes the soil to dry out faster. And some people use shallow cultivation, like with a wheel hoe, or just like something cultivating the surface just like 1 to 3 inch depth. And then some people, based on the equipment they have, for example, maybe they just have a tiller. So they'll do a deeper cultivation. And historically, this has been called a dust mulch. Which kind of brings up red flags for a lot of folks, including me. It sounds like kind of a dirty word, but it's we're very much focused on soil health in a lot of this dry farming work, because improved good soil quality and soil health is really important for water holding capacity. I have some pictures here on this slide that show some other approaches that we've seen. So leaf mulch, straw mulch, kind of the cultivated surface. You can see a couple pictures there at the bottom of a more kind of a traditional dry farm approach on commercial farms in California down there at the bottom. And then on the bottom right is a weed fabric. There's someone that had really high bindweed pressure, which is a perennial or a weed that has really deep roots here and doesn't mind dry farming at all. but people are looking for solutions based on what they have. So weed fabric in his melon patch was a good option to suppress that bindweed. So there's a lot of creativity that goes into this, and being mindful of what equipment you have, and you know, your creativity. So timing is another really key component. With all the things that we're doing in managing soil in a dry farm system, we're trying to do things early. So plant amendments and soil prep are, you know, more traditionally in a dry farm setting, done much earlier, because you're really designing the whole system around your limiting resource, which is water. So I think for Matt is going to be talking a bit about a study, a soil management trial that has been designed to answer some of the questions that folks have around how these different practices affect soil moisture and crop productivity in a dry farm setting. So I'd like to hand it off to Matt.
Great, thank you so much, Amy. Yeah, as she says, we are going to be focusing today on an experiment that we're conducting at Oregon State University. This is a virtual field day, so I'm going to be trying to do my best to take you into the field so that you can see the work that we are doing. Today's presentation is called Soil Management for Dry Farm Vegetable Production. Some of the people collaborating on this project include me, Matt Davis, Brad Rimsey, Alex Stone, and Amy Garrett, all from Oregon State University, and also Andy Gallagher from Red Hills Soils. This project is funded by the University Corporation for Atmospheric Research. That will be this year's funding. And then we're going to do this experiment again next year, and it'll be funded by Western SARE. So really quickly, I know that most of you are probably familiar with dry farming, but I want to bring everyone up to speed just in case you're not. So what is dry farming? Dry farming is the production of crops during a dry growing season without irrigation. So no, the fava beans that you overwintered and didn't water once, those don't technically count as being dry farmed because they were grown during primarily during a cool, wet winter and spring. Similarly, you can't really dry farm on the East Coast because it rains during the summer. So how do dry farmers get moisture to their crops then? Plants need water, and you know, this isn't magic. We're not just like growing crops without any water. Well, the dry farmers actually utilize residual moisture in the soil that's left over from a rainy season rather than using irrigation. In our case, we get about 40 inches of rain during the winter and spring, and that residual moisture is held in the soil, and that is how crops get water. And dry farmers have a number of techniques that they use in order to try and maximize the amount of water their crops get. This includes early mowing and incorporation of the cover crop. So if you terminate the cover crop early, then that cover crop isn't competing with your food crop for moisture. Similarly, early planting will allow the crop to access the moisture early during a cool season, and maybe get some of that early precipitation before the hot, dry growing season. Diligent weed control is also really important. Weeds compete with the crop for all sorts of resources, but especially moisture. And then finally, mulching is another strategy that can be used to try and conserve water in the soil by preventing evaporation. I think it's important to point out too that dry farming isn't anything new. We didn't invent this at Oregon State. It's been practiced probably since before human civilization by a number of people, and those people don't necessarily get the same level of recognition or funding that we do here at the universities. So it's important to remember, you know, our forebears. Finally, if you're interested in learning more about dry farming and getting an introduction to dry farming, the website highlighted here at the bottom will take you to a page which has a number of videos, including past webinars, where you can learn all about dry farming and the work that we're doing. So today we're going to be talking about soil management, and I think it's important to go into why soil is important for dry farming. And it's because soil is where the water is. Soil is the major water storage reservoir in terrestrial ecosystems. Soils are about 25% water, you know, when they're fully saturated. Of course, the water gets drawn down by plants during the growing season, but yeah, that is where the water is. And even if you irrigate, you have to irrigate the soil, and then the plants will get that water from the soil. The soil is filled by precipitation, and it's emptied by evapotranspiration. So evapotranspiration is evaporation of water from the soil, much like clothes that are put out to dry, the water from them evaporates. And transpiration is the evaporation of water from the leaves of plants. And that's actually a major contributor to the water loss from soils. And the water that's in the soil is held between soil particles within the pores. And so different kinds of soil can hold different amounts of water, which is something we covered last week, and we're not going to really get into that much this week. Last week, though, we did talk about site suitability factors, what sort of things make a site suitable for dry farming. And when we talked about the soil, we talked about these sort of inherent soil properties, including the available water holding capacity of the soil, which is how much water a soil can hold. So like I said earlier, different kinds of soils can hold different amounts of water. Sandy soils hold the least water. Silty clay loams can hold the most water. And then the other really important inherent soil property are these firm layers. So these firm layers that are sometimes present in the soil can prevent the roots, we think, from growing deeper. And so it effectively can reduce the amount of water that the soil holds, because even though there are water in these soil layers, if the roots can't get to them, they're effectively not there. So now we kind of talked a bit about soil and the inherent soil properties. We're really interested in finding ways of managing the soil to reduce soil moisture losses throughout the season. And then we're also interested in how can we manage the soil that reduces yield losses to blossom end rot. This is the two kind of focuses of our study this year. And we created a number of treatments that are going to allow for us to test different dry farming soil management strategies to see whether they reduce soil moisture losses and whether they reduce yield losses to blossom end rot, which is this physiological disorder that can effectively destroy a dry farm tomato crop. So our first treatment is a dust mulch treatment. Dust mulching is very traditional to dry farming. The idea behind it is that by breaking up the soil, you can prevent these capillaries from drawing soil moisture up from the subsoil. However, dust mulching may also make the soil vulnerable to wind erosion. So it's not like the ideal treatment, but it's definitely the one that is most utilized as of right now. And the way that we've been applying this treatment is that we rototill after every rain event, which has been about 3 times this year. And our hypothesis for this treatment is that the dust mulch reduces soil moisture loss to evaporation, yielding higher marketable yields. Our next treatment is a weedy treatment. So, the weeds we've allowed to grow and colonize the plot. And our rationale for including this treatment is that the weeds will steal resources from the crop. Our hypothesis for this treatment is we expect that they will use soil moisture more quickly and have lower yields and poorer quality fruit. Our third treatment is a deep mulch treatment. For this treatment, we put 4 inches of leaf mulch applied after planting. The rationale for this treatment is that the deep mulch will prevent evaporation from the soil and will also prevent weed colonization. And our hypothesis is that the deep mulch will reduce water loss to evaporation and increase fruit yield and quality. Our next treatment that we're doing is a high rate of organic matter. So this is about 54.1 tons of compost added per acre. So it's a lot of compost getting put on the soil. The rationale for this treatment is that organic matter will increase soil water holding capacity. And our hypothesis is that the higher levels of organic matter will make the plants less drought stressed and will have higher yields. And then finally, we're doing some treatments to test how different soil amendments might affect blossom end rot. So up here on the top right corner, you can see some tomatoes showing the symptoms of blossom end rot. When tomatoes get this physiological disorder, they are unmarketable, and it's actually a big problem for dry farm tomatoes in the Willamette Valley. Last year, we did these site suitability experiments and found that about 33% of the tomatoes in any given farm were having blossom end rot. One of the thoughts behind blossom end rot is that it is calcium, like that there's not enough calcium in the soil, or the calcium isn't getting to the fruit. And so we decided to put in this gypsum treatment to increase soil calcium and potentially reduce the rate of blossom end rot. And we added about a ton of gypsum per acre for this treatment. And our hypothesis is that the gypsum plots will have lower rates of blossom end rot. We're also doing low and high fertilizer treatments. So the other hypothesis that we have, aside from calcium, is that the blossom end rot is being caused by there being this really excess early season growth followed by extreme stress. And we think that maybe having high fertility soils may actually make the plants grow really fast so that they're more susceptible to the stress and the blossom end rot. So we have two treatments here. We have a low nitrogen treatment, which received about 40 pounds of nitrogen per acre, and then a high nitrogen treatment, which received 160 pounds of nitrogen per acre. And our hypothesis is that the low nitrogen treatment will have lower rates of blossom end rot, and the high nitrogen treatment will have higher rates of blossom end rot. And so in order to test all these different hypotheses that I just laid out, we put together an experiment. We planted in the fall a cover crop of common vetch triticale and fescue, and then we terminated that cover crop on April 7th, 2020. We applied our fertilizers, so our different soil amendments, the gypsum, the nitrogen fertilizer, the compost, on May 7th. And we tilled those fertilizers and soil amendments in on May 8th. We planted the experiment on May 12th. And then we applied our leaf mulch on May 27th. And here you can see a little video of us planting our trial. Here we're using what's called a potato to quickly plant our tomatoes. It was a fun day. So here is the experiment. This is all those plants planted out. All the treatments have been applied at this point. You can see the leaf mulch should be pretty obvious with those darker gray squares. We're going to conduct this experiment again next year. And it's a replicated research trial at Oregon State's Vegetable Research Farm. There are 32 plots and 672 plants in the experiment. And the crop that we're growing for the experiment is early girl tomatoes. This is a common dry farm tomato. So let's zoom in on a plot and get a better idea of what the plots are made up of. So here's a plot. Each plot is made up of 21 plants. 5 of the plants at the center of the plot are the actual experimental plants. These are the plants that we're taking data from. And then the 16 plants around those 5 plants are the border. So that's to make sure there isn't any kind of spillover effect from one treatment to the next. And then between each of the 5 experimental plants, we installed these watermark sensors. We installed them at 1 foot, 2 foot, 3 foot, and 4 feet. And these are to measure how the plants are using moisture throughout the growing season. So here I have a little video of us installing one of these watermark sensors.
So the dry farming project, we like to use these watermark sensors in order to determine how much water is in the soil. These sensors measure how much tension the water is held to the soil with, and they go from 0 centibars, which is totally saturated soil, all the way up to 199 centibars. The probe right here is installed in this thin-walled half-inch PVC pipe, and once we have our hole dug, we can install it into the ground. So a couple of weeks after installation, you're ready to take your first reading. At that point, the sensor should have equilibrialized with the soil. The way you do that is with this reader. You attach the two alligator clips at the end to the two leads on the end of the sensor, and then you press read on the reader twice, and that gives you your first reading. What's it say?
199.
All right. Cool.
So that's how we installed the watermark sensors that we are using to collect that soil moisture data. So here now we can see this is one of the blocks of the experiment with our 8 treatments. We have the weedy treatment I talked about. You can see there is a lot of vegetation in there that isn't tomato. You can see our leaf mulch treatment that's got the 4 inches of leaf mulch on the surface. Here is our dust mulch treatment, which we rototilled after every rain event. A gypsum treatment, which received about 2,000 pounds of gypsum. Our high nitrogen treatment, which received 160 pounds of nitrogen per acre. Our low nitrogen treatment, which received 40 pounds of nitrogen per acre. High compost treatment, which received about 50 wet tons of compost per acre, and a control, which was sort of like the, baseline for all these different treatments, something to compare them to. And here you can actually see the soil amendments. So every, on the left-hand side of this table, you can see our different treatments: control, leaf mulch, dust mulch, weedy gypsum, high nitrogen, low nitrogen, high compost. The next column over is the amount of compost each treatment received. So the standard was about 4.5 wet tons of compost per acre, with the exception of the high compost treatment, which received 59.6 wet tons per acre. The next column over is the Stutzman 432 composted chicken manure fertilizer, and then feather meal fertilizer. And you can see that all the treatments received about the same amount of Stutzmans and feather meal, except for the high and low nitrogen treatments. And then the final column is that gypsum treatment, the pounds of gypsum per acre. And you can see that our gypsum treatment received about a ton of gypsum per acre, whereas all the other treatments received no gypsum. And then here we have the entire experiment. These are 4 separate blocks, and within each block, you can see all the treatments are replicated. So we have one of each treatment within each of these 4 blocks. So now I'm going to talk a little bit, we'll show you some videos about our data collection. So this first video is on collecting soil samples in order to determine the soil nutrient content.
So taking soil samples is a good way to understand your site's soil chemistry, soil nutrition, and pH. It's also important if you're conducting experiments and you want to understand whether there are treatment differences between your different soil amendment treatments. Here we have Brad, one of our student field assistants, collecting a soil sample. He's randomly taking little samples from our plot here between these 4 flags, and he's putting them in that bucket, and later we'll send that off to a lab to get analyzed. Hey Brad, would you mind taking a sample up here for everyone to see? Sure will. All right, so that's that.
So we took our samples at about a depth of 6 inches, so from the soil surface to 6 inches deep. And we actually found that there were differences between the different treatments in the amount of the nutrient contents of the soil. So I know you're looking at all these, boxes, and you're probably a little concerned about, understanding all this. But just take a moment and look. You can see along the bottom of each of these figures is all the different treatments. So compost, control, dust mulch, gypsum, high nitrogen, leaf mulch, low nitrogen, and weedy. And then along the left side of each of these figures, you can see the name of the nutrient. So the top left box says nitrate, below that phosphorus, potassium, and then on the right, starting at the top, calcium, sulfur, and boron. And each of these is the nutrient content in parts per million. And I just want to point out really quickly that the compost treatment has the highest nitrate level, followed by the high N. The compost also has the highest phosphorus, potassium, and boron levels. The gypsum treatment has the highest sulfur content, much higher than all the other ones. And then with the calcium, you can see the gypsum has the highest soil calcium. It's not statistically different from the other treatments, but it is higher. And that, I think, points to how it received that gypsum treatment. So this next video is going to highlight another one of the methodologies that we're using. We're using what's called a pressure chamber to determine how drought stressed plants within these treatments are. So this video will show you how we use this pressure chamber.
So one of the tools we use with the dry farming project is this pressure chamber made by PMS Instrument Company in Albany, Oregon. This tool is used to determine how drought stressed plants are. We'll come out here before dawn and we'll collect leaf samples, and then we will take readings from them. And I'm going to show you right now how to take one of those readings. So the first thing you want to do is you want to find a leaf. You want it to be the right size to fit inside of the chamber. So nothing too big, but also nothing too small. Looking for the Goldilocks leaf. This one will do. You take the leaf, stick it into the machine. The cut end right here, which is cut with a razor blade, of the petiole is sticking out, and the leaf will be inside the chamber. And then what you do is you fill the chamber with nitrogen gas, and as the chamber pressurizes, it'll eventually push water out of the leaf, and that's when you'll know to take the measurement. The reason I'm looking at it from this angle is because the most dangerous thing about this machine is sometimes it'll shoot the leaf out and the petiole can hit you in the eye. There we go. The reading is 9.5 bars.
So that's one of the tools that we're using to, determine how drought stressed all the different treatments are. Another thing, arguably more important, that we're doing is we're collecting the tomatoes and we're weighing those. So this is a little video on how we collect and quantify our tomato yield. I'm here at the Vegetable Research Farm with Brad Ramsey. Today we are harvesting tomatoes from our soil management experiment. The tomatoes come from 5 plants within the center of a 21 plant plot. So that's 5 border plants. 16 border plants and 5 experimental plants. You can see Brad is just finishing up harvesting the last plant. Now he's going to walk over to the scale where we're going to get some data from these tomatoes. So the first thing he's going to do is he's going to get a total count and a total weight for all the tomatoes that he's harvested. This will give us an idea of how much biomass is coming off of our plots.
So we end up with 1.2 pounds.
So that's 5 tomatoes, 1.2 pounds worth. Next, he's going to take these tomatoes and he's going to break them up based on their status. So that one he just picked up is a, here, why don't you hold it up for the camera? It's a blossom end rot heavy. So we have a blossom end rot heavy and blossom end rot light designations. The idea being that those would be like seconds and then totally unmarketable. So first he's weighing the blossom end rot heavy. There's 3 of them. How much did they weigh, Brad?
0.64 pounds.
0.64. This next one has sunburn. You can see it right there. It's pretty bad. So it's 1 sunburned tomato.
0.22 pounds.
That's 0.22 pounds. And then this final tomato looks marketable. It's like a good tomato.
And it's 0.32 pounds.
And that's at 0.32 pounds. All right, and that's an example of how we collect data here in our soil management trial. Thank you so much, Brad.
Thank you.
So we're still early on in the experiment. We don't have a lot of data yet. However, I do want to share a few of our results with you. First thing to share with you is that the weedy treatment has the smallest plants, is the most drought stressed, is using soil moisture the fastest, and has the most blossom end rot. So I highly recommend, if you are a dry farmer or a dry gardener, please weed your plots. Also, an interesting result we found is that the leaf mulch treatment has the biggest plants and is using water the slowest. Which is in line with our hypothesis that the leaf mulch would prevent evaporation. However, one thing we did notice was that there were also a lot of roots growing in the leaf mulch, so it may be that the leaf mulch didn't necessarily prevent evaporation. Instead, it created a whole new space for the roots to grow and extract moisture, and now they're slowly moving deeper into the soil profile. Some other early results. Here we have plant size on July 20th. On the left-hand side of this table, you can see our different treatments. They are in order of size. So the largest treatment was the leaf mulch treatment, followed by the compost, gypsum control, high nitrogen, the dust mulch, low nitrogen, and weedy. Next to that column, you can see the mean size in cubic meters. So this is the volume of the plant that we measured. The leaf mulch was 1.44 cubic meters. The weedy treatment, the plants were about 0.68 cubic meters, so a lot smaller. And then on the far right side, you can see our mean separation. So this is a statistical concept. It says whether or not these the differences that we're seeing in the means between these treatments are statistically significant, whether or not the difference between them is due to the treatment as opposed to whether it's just random chance, and that the difference between these means should be ignored. So you can see that the leaf mulch and the compost treatments, they both have that letter A, and that means that that they're not technically statistically that different. So even though the compost here, it says that the mean is a little smaller than the leaf mulch, we should disregard that difference when we're trying to make any sort of claims about which is bigger. However, the leaf mulch is a lot bigger than the dust mulch, the low nitrogen, and the weedy treatments. And that difference is statistically significant. And you can tell that because the letters are different. The leaf mulch is represented by this letter A. The dust mulch, low nitrogen, and weedy treatments do not have that letter A. And then here is drought stress. So again, on the left, you have the different treatments in order from the least drought stressed, which is the gypsum treatment, to the most drought stressed, which is the weedy treatment. Next column over is the mean pre-dawn leaf water potential in bars. And that goes from negative 0.4 to about negative 0.6. So when we talk about leaf water potential, we use negative numbers, and the more negative, the lower the number, the more drought stressed the plants are. And again, we have that mean separation on the right. So the gypsum and the control, although the control is, seems like it's a little more drought stressed, that difference isn't significant. However, the gypsum and the control are both less drought stressed than the leaf treatment, the low nitrogen, and the weedy. So that about covers all that I wanted to talk about on our experiment. Amy would like now to talk a bit about some of the explorations of soil management that the Dry Farm Collaborative is doing. So what I've been talking about, it's been an experiment that we're conducting, but that doesn't mean that other members of the Dry Farm Collaborative aren't doing interesting things with soil management. So Amy, feel free to take it from here.
Okay, can you hear me now?
Yep.
Okay, great, thank you. So yeah, alongside our formal research trials, there's a lot of members in the Dry Farming Collaborative that are experimenting with alternative approaches. There's a lot of interest in low and no-till approaches for dry farming. People are experimenting with different kinds of mulches, as well as hugel culture, which is an approach of burying wood and letting it rot and decompose, and increases fungal growth and potentially helps hold water for the crop. We haven't done any experiments like this on OSU research sites, but I think that is the power of this collaborative research approach. There's a lot of farmers and other researchers trying different things, and then we convene and talk about our lessons learned. By the way, if anybody is doing anything with low and no-till, I would love to hear about it in the chat box. That would be an interesting discussion, or just kind of to hear about some of the different approaches you all are trying in the way of low and no-till. So this picture on the right was provided by Jim Leap. So he used to work for UC Santa Cruz and has done a lot of dry farming. This is a tomato crop, a bush early girl. And you can see on the left is his experiment with mowing, and then he did irrigate in those tomatoes on the left. But you can see he mentioned in his notes about this picture that even though they were irrigated in, the ones on the right were not. The plants on the right with that kind of cultivated surface are quite a bit bigger. And those are the same variety planted on the same date, is my understanding. So this is just an example of what some of these different experiments look like on different folks' farms. Can you advance the slide? So here is a video that we're going to share. So in explorations with cover crops, a lot of people are doing different things with cover cropping. And this first segment, we're going to learn a little bit about kind of some of our explorations with summer cover crops that can then winter kill and potentially be planted into. And then after that, we'll talk a little bit about fall cover crops that can then be terminated in the spring. So I'm ready for this video.
Hi, my name is Mara Friddle, and I am a horticulturist here at the Corvallis Plant Materials Center. The Plant Materials Center is an arm of the United States Department of Agriculture, and we produce plant technologies for farmers and landowners in the Pacific Northwest ecoregions. One of the things that we study are different cover crop solutions for farmers in this area. For a couple of years running, we did cover crop variety trials, testing out different varieties of commonly grown cover crops for this area. One of the data points that we took in that trial was biomass. So behind me here, you'll see Piper Sudan grass, which in both the irrigated and non-irrigated cover crop trials that we did was a huge standout as far as biomass production. So there were a few standouts. Another was Viking soy, which we don't have growing here. This is a stand of just the Piper Sudan. And also, you'll see behind me, this is about the time of year that we would be sort of taking the heads off, stopping the flowering of the Piper Sudan grass in order to get more biomass production. One way to do that is to mow high, like we've got in this row here. And then another way to take the flower heads off, as you can see behind me, my coworkers, the mobile methane digesters, are taking down the flower heads of this cover crop as well. Oh, goats. There you go. Yeah.
All right, so that, as you saw, was Mara Friddle at the USDA Plant Materials Center. And I think Annie Young-Matthews is on this call, and she was also a part of those experiments. So if you have anything to add in the chat box, I'd be really interested if you even have I'll share a link later when we follow up with an email to all the people who participated, but there's a link to the report from their trial. So this next video is me taking what I learned from Annie and Mara and those cover crop experiments at the Plant Materials Center. So they were dry farmed summer cover crops, which I hadn't any experience with. So we are doing a small study taking some of the successes with sorghum Sudan, although we have a different variety of sorghum Sudan than the Piper that they mentioned, as well as the Viking soybean. And so we have a few different treatments that I'll highlight here in this video. All right, it's August 4th, and we're here at the Oak Creek Center for Urban Horticulture in Southwest Corvallis. And I'm standing in our summer cover crop trial. So with the Dry Farming Collaborative, we have a lot of formal research projects, and this is more of an exploratory project. We encourage a lot of our growers and researchers to be having exploratory projects as well. So this is one of those for me this year. And we have over to my right, your left, we have buckwheat. And you may not be able to see, but there's bees all over the flowers in this morning. And then I'm standing right here in a sorghum Sudan soy mix. And you can't really see the soy, but I'm going to show it to you. So this is what we've got kind of growing underneath, kind of in the understory of the sorghum Sudan. And then over here, to the right, my left, we have just a sorghum Sudan plot. And there is a lot of pigweed coming up in this stand. And I will tell you that our first planting in May, we had a really cool wet May this year, and the sorghum Sudan did not get established very quickly, and this pigweed kind of took over. So we actually replanted this and had to irrigate it in June. So we've got a much better stand this year, or this planting. And the idea here is that we're going to manage this, maybe mow it once, possibly twice, just so that it doesn't go to seed. And then perhaps roll it down in the fall and potentially plant into it in the spring, like transplant into it, potentially tomatoes or squash. So we're looking at low and no-till approaches in dry farm settings. And this is just the beginning of that. So we have a lot to learn, but we'll report back on that after we see how that does. So this final video is looking at fall cover crops. So at the Plant Materials Center, we got to hear from Mara a few minutes ago about some summer cover crops that they had trialed, both dry and irrigated. And then I took that and kind of applied what I learned onto a small plot as an experimental study. And this is an example of what they're doing to take fall cover crops, so that are typically planted in the Willamette Valley in September or October, legume cereal mixes that then overwinter and then are terminated in the spring and then could be planted into after that. So this is another cover crop approach. And let's see what Mara has to show us here with their demonstration.
So this 3-foot section right here was rollered with the roller crimper, but it was not, there was no other herbicide applied after the roller crimper. So I want to point out here that the roller crimper does not kill plants as it goes through. So any of the common vetch did fully go to seed. There are actually viable seed on the rye. And as you look down, there's quite a few weeds that have popped up through even still. So this next section that we're looking at here was rollered on the same day, and then one application of Roundup was made, or glyphosate was made. You can see here that it still provides excellent cover, and there's no weeds, there's no seed on any of the rye. The common vetch died, the crimson died, but they're still providing an excellent mat of cover. So starting here, and the next section, we rolled at the same time as the Roundup, but we applied Weed Slayer, which is an organic alternative to glyphosate. Again, there's virtually no difference between the glyphosate and the Weed Slayer section, although there's one or two little weeds starting to pop their way through this, but still, it really did an excellent job of terminating and keeping the weeds at bay. This next plot was tilled one time at about a depth of 3 to 4 inches, and you can see as well, I think that was done 4 weeks ago, and there are some weeds that are starting to pop back up through this. It also is, I wouldn't call this an ideal seed bed in any way, and the biomass in is still pretty large and not perfect for growing stuff. Okay, so this section here was only mowed. You can see that there is a nice layer of sort of mulch on the ground, but it has done nothing to stop the weeds from coming up. And again, this was done about 4 weeks ago at the same time as the tillage. And then this last section here was tilled twice. It was tilled at the same time as our single tillage plot, but this was tilled 2 weeks later as well. So that gave the weeds an opportunity to germinate, and then we mixed it back in. So it does a pretty excellent job of taking down the weeds. However, it is a pretty bare soil exposed to the elements, sun and wind.
And that picture to the right here is we pulled back the residue and the cover crop that had been rolled and then terminated with Weed Slayer, which is the organic herbicide she mentioned. And there was quite a bit of moisture under the surface there. And this video was just taken last week. And so yeah, in these studies, like we've highlighted here, and I'm sure there are a lot of farmers even participating in this webinar today that are trying different things. I've talked to a farmer who uses cardboard. Some people use appliance boxes or get rolls of cardboard and roll those out and do sheet mulching and put wood chips, which are pretty free and readily available here. So I think exploring low and no-till approaches is a way we'll kind of keep, an approach we'll keep exploring. So that's, I think, all we have here for the presentation. And there's some photo credits, but here's a list of all of our sponsors for these. And just a note, as we get into the Q&A session, that these are happening every Wednesday. If you weren't able to attend our first field day on site suitability, which was last week, that video recording is up on our website there at the bottom. And if Brad or Tegan, if you wouldn't mind just copying that into the chat box so that folks can easily access it, that would be great. And so feel free to chime in the chat box, and if there's any questions, we'll do our best to address those for the next few minutes. Brad in the chat box has there's a survey there. We're trying to constantly improve and get feedback on these virtual field tours as we are brand new to doing this. So if you wouldn't mind, after filling out that survey, we'd really appreciate your feedback.
So now we have an opportunity to go through questions and do some answers. I see one question here from Andy. How did you measure plant size? The way that we measured plant size in the field was we measured the height of the plant to the tallest, stalk or sucker, and then we measured the width of the plant across, and we tried to get like approximately where the edge was, not including any like suckers that were sticking really far out. So kind of, we had a standardized method, and we did make a little video of us doing that, but for time we didn't include that. So, but yeah, we used the standard method, and we tried to, approximate the volume of the plants.
There was a question here from Bonnie, and I think that it's been partially answered, but she said that she was assuming that we had to irrigate in the summer cover crop to establish it. And I think towards the end of the video, I mentioned at Oak Creek that for that, at the Plant Materials Center, Annie added the comment that they didn't have to irrigate it in. They just planted early and took advantage of the spring moisture on the surface to get the plants established. And that was our goal too, but we had an unusually cool, wet May. So my theory is that the cool, wet May was, and the cool soil temps weren't high enough to get that sorghum Sudan germinated and growing quickly, so it got beat by the pigweed. So we did another planting in June, which we did have to irrigate in, but there's multiple farmers that I've talked to that have success in getting sorghum Sudan grass established with just the residual moisture in the soil and don't have to irrigate it in. So I aspire to do that, but just didn't happen this year.
I see another question here from Bonnie to everyone. How do the plant sizes compare with marketable production in pounds? I think this is a really important question. We don't know right now. Definitely the leaf mulch treatment and the compost treatment were our two biggest, but that does not mean that they're going to be the most successful. And, I think that there's a lot of evidence that the major cause of blossom end rot is this rapid, luxurious growth followed by severe stress. And as of right now, we're not really seeing any differences between the treatments and the amount of marketable yield, except for the weedy treatment. The weedy treatment has a lot more blossom end rot, which is resulting in lower marketable yields. But I think as the season goes on, the plants are going to get more drought stress, and it'll be interesting to see whether these plants that grew really big, like the leaf mulch treatment or the compost treatment, whether that growth makes them more susceptible to blossom end rot. And then potentially, you know, they might get a higher proportion of blossom end rot, but if they also yield higher, then, you know, that effect might be negligible for marketable yield. So a lot to learn still. And, you know, just because the plants are bigger, that does not necessarily mean that they are better.
Looks like there's a question here from Brad. Do we intend to use the same cover crops this winter? So we have a different recipe at different sites. So it's typically been rye, crimson clover, and usually a few other species at Oak Creek. So part of that plot, we'll be doing a fall cover crop again, like a mix of cereal and legume cover crops to get a nice cover on one part. But the part that I was talking about, the summer cover crop trials, our plan is to just not let those go to seed, just like Mara was showing in that video, kind of doing a high mow or even scything, which would be kind of fun, to just get knock off the seed head, so we're not you know, letting that go to seed, and then rolling it down. Hopefully we'll have a nice thick stand of residue, and that maybe we could plant earlier, because in the Willamette Valley we have these cool wet spring conditions, and it's usually like often it's hard to get in the field or kind of to find a window to get planted early. So we're kind of dancing with the weather. So if we just have residue laid down and it's nice and thick, and hopefully no weeds coming up, or very few, then I'm thinking I would like to try transplanting into that. So either our tomatoes or squash, which, you know, end up this time of year, you can't really see any bare soil, because even though the plants are spaced out wider, they're providing full cover. So any weeds that might pop up through that dense residue would be minimal after the plants got established. And there may be, we might actually add some more mulch. So this is kind of just a pilot project. We're going to kind of play with some different approaches. And if we start to see some successes, then that might translate into, okay, let's engage some more growers and try to get some funding to look at this more closely. Okay, I don't see any other questions here in the chat box. There is a link there that Tegan posted where this recording will be archived along with all the other virtual field tour recordings. And there's also a link for a survey we'd love you to fill out. So thank you all for taking the time to join us today, and hope you'll be able to join us for some of our other field tours. And the next one is this coming Wednesday, and it will be focused on our potato variety trials, which we've been doing for the past couple of years. All right. Thank you, everybody.
Thank you.